Hello, and welcome to another tutorial video for CSCI 2824, Discrete Structures. Since you've been going over proofs in class, we're going to focus on direct proofs for this video, and go over an example. The definition of a direct proof is as follows. First, an initial assumption is made. Next, straightforward arguments follow. And finally, the claim is proven true. Well, this sounds pretty simple at first. These proofs can actually get to be a little bit tricky. We're going to go over an example to illuminate the process of writing a direct proof. Here's our example. If A divides B and B divides C, then prove that A divides C. To begin, let's just make sure that this makes sense to ourselves. Let's say that A equals 3, B equals 9, and C equals 27. This means that A divides B, B divides C, and we know that A definitely divides C. So this makes sense. Now we're actually going to write a direct proof. When we're starting a proof, we always want to make sure to specify what type of proof it is. We can simply do that by writing direct proof. Next, we're going to make our initial assumption. Suppose A divides B and B divides C. Now, I'd especially like you to note here that I did not try and assume what we're trying to conclude, that A divides C. That would essentially be circular reasoning, and so it wouldn't make sense for our proof. Okay, now that we have our first step laid out, we can begin to make a little bit more progress. So we know if A divides B, then B equals AK for some integer K. This is essentially saying that A times some number is B, which makes sense. Next, we'll do a similar step. If B divides C, then C equals BL for some integer L. Again, this is just saying that C times L gives us B for some number L. Now that we have these in place, we can start to make a little bit of progress in our proof. If B equals AK, this means that C equals A times K times L. Essentially, all we did was plug AK in for B. Now, if K and L are some integers, then we can rewrite them as another integer, say M. This means that C equals A times M. And if M is just some integer, then we've proven that A is a multiple of C. At this point, we've essentially finished our proof. If A is a multiple of C, then by definition, C must be divisible by A. And if you remember, this is exactly what we were trying to prove before. So, now that we've finished our proof, we just want to indicate in some way that we're done. So I'll just write claim proven. And there you go. That's a direct proof. So remember, direct proofs start with an assumption. And this assumption does not include what we're actually trying to prove. We then go through some straightforward steps, with each step following direct logic from the previous steps. And finally, we prove our claim. Once you nail down these steps for indirect proofs, they actually become fun little puzzles to solve. Thanks so much for watching, and good luck.